Hello everyone. In this video, we are going to discuss about redundant group. We are going to see what is a redundant group means, and if you identify a redundant group, what has to be done with an example. Now, a redundant group is a group whose all ones are overlapped by other groups. So, if you find some groups, if one group is being overlapped by other groups, you call it as a redundant group. So, we will see an example here. Okay, so you can see a K-map is given and you got 4 ones here. Okay, when you observe it, how many groups are that is how many pairs are available. So here basically you have 3 pairs. So you are going to identify what are the pairs available. So first pair is you can see here 5 and 7. Okay, this makes a pair. Okay, so pair 1 is M5 and M7. Now the second pair you can observe here is 7 and 15. Okay, so this also makes a pair. You cannot mark 5 and 15 as a pair because diagonal values cannot be taken as adjacent values. Say here 7 and 14 also is diagonal values that cannot be taken as a group or you can say as a pair. You can take only left to right or top to bottom. Okay. So that is the second pair, that is M7 and M15 has been identified. And you got one more pair, that is 15 and 14, that is pair 3. Okay, so M15 and M14 are the midterms. Okay, now after identifying 3 pairs, you can observe that pair 2 is a redundant group because you can see both the ones are marked by other groups. So you can see the value which is that is midterm in 7, okay, is marked by the pair 1. Okay, it is already been marked by pair 1, and here in 15 1 which has been marked by the pair 3. Okay, that means pair 2 is the redundant group because it is completely marked by other groups. Okay, now what has to be done if you find like this? Okay, now if you reduce the expression, okay, with along with the redundant group, what happens is you will take the first pair. Okay, so here you got 5 and 7. Okay, midterms 5 and 7 has been marked. So for this you will have w dash x, that will be constant for both, and if you take the column y dash and z dash for column 2 and y and z for column 3. Now y dash is changing its state to y, so you have to remove y, and you can see z has been constant, so it is same. So the value, that is expression, what you're going to get is w dash x and z for pair 1, and for pair 2 you can see y z is constant here. Okay, for 7 and 15 it is constant, it will be same. We can see here rows w dash has been changing it's changing its state to w, so you are going to remove w, and you can see x which is not changing its state, it is constant, so you are going to take x, y, z. So that is the second pair expression. Now the third pair you can see, notice here is 15 and 14. Okay, so wx will be constant for both the boxes, that is 15 and 14. And if you see the column, y is constant for both the boxes. Okay, but you can see z value is changing its state to z dash. So z will be removed from the expression. So you will get wx and y. So that is the last term here. Okay, this is along with the redundant group. But after observing, after you identify the group, what has to be done is, to make it simpler, you are going to remove the redundant group. So redundant group must be removed because it is already been marked by other groups, so it is better to remove it. So once you remove it, you will have only 2 pairs here. Okay, so you might be asking, why can't we do this in the beginning itself? But you have to identify how many groups are available in the K-map. Then finally you have to identify the redundant group and remove that. Okay, that is the process, that is the rule. Okay, so once you remove that, finally, after removing the redundant group, you will have a simplified expression. Okay, that means you will have only 2 terms available. So that will be the first term, that is w dash xz, and the final term w xy. Okay, this will be the expression you will get after removing the redundant group. Okay. So hope you understood this video. We'll meet you in the next video. Till then, thank you.